is streaming, right?
Yeah.
Okay. Let me share my screen and start. Okay. Hi, everyone. Thank you for joining in today. Hope you guys can see my screen. If you are new to this identity server community call, let me go through the things in this community call readme file, right? So with this link, you can go to the identity server product page. So you have all the links to download the product, documentations, other resources available in identity server. So if you go to this link, you can know all about identity server and download all the resources. Then we have the link to our Slack channel. At the moment, we have around 590 users in our Slack. So if you are not joined to the Slack channel yet, please join there. So you can discuss anything about the product. If you have any questions, almost all the identity server developer team and the community all are in this Slack channel. So you can easily get resolved any questions you have, or you can contribute to the discussion here and see what's happening, and you can give your own input too in our Slack channel. So if you are not here, please join to the Slack channel. Then the next link goes to identity server Twitter account. If you follow this identity server community Twitter account, you can get the latest update about the product and the things we are doing within identity server. Then the next link here, we have a Git repo where we track all the blogs that we write, all the identity server team members. We track it here. So if I go to this page, so you can see there are a number of blogs we have tracked, but when it goes to the August, we have very limited number of blogs. One reason is the whole team mainly focusing on the 5.11.0 release and hardly working on that. But still we have set of blogs. So I picked few blogs here. In this session, I'll quickly go through these blogs and give in today's agenda, I have list down all the blogs that I'm going to discuss. So if you want to come and find those links, you can come to this today's course agenda page and find it. First, I'll select the blog article written by Prabhat. So this is about challenges of securing microservices. Let me go to the page. Yes. In the beginning of this article, you can see a link to Microservice Security in Action book, which is authored by Prabhat and Mohan Dias and other colleague in WSO2. They discuss about the challenges in microservice security and how we can solve those issues as well in this book. But in this blog, Prabhat mainly discuss about the challenges we see in microservice architecture in terms of security. So you can get some clear idea of these challenges. If I go through few challenges, one is compared to the monolithic application in the microservice architecture. In monolithic application, all the components run in a single process. But when it comes to the microservice, there are individual microservices representing different components. So this communication between these components can be considered as remote. And again, if it's a monolithic application, there can be one or two entry points to the component or the whole system. But when it goes to the microservice, there are different entry points and different microservices. So in that case, it increased the system interaction surface. At the same time, it will broaden the attacker surface. So this is one of the main challenge we see in the microservice architecture. So if you want to make the whole system secure, so we have to make each point secure as well. So unless we can't consider that whole system is secure. So this is one challenge. Likewise, there are many challenges Prabhat has listed in this article. So you can read more about this article. So if you get that book, you can see how that can be solved as well. As the second blog, I selected this one. This is written by Sanduni. Sanduni recently joined to the identity server team as an intern. She is closely working with Deep and Asinta. So in her intern project, she's going to implement external wallet support for WSO2 identity server and other WSO2 products. If you know the identity server or if you have used identity server, we have a secure vault implementation where it uses the internal key store and keys in there and encrypt the credentials in our configuration file. But when we deploy in the identity server in the cloud, there are sophisticated mechanisms we can securely keep that secret, such as AWS Secret Manager, Azure Key Wallet. So with this project, Sandhuna is going to extend the identity server secure wallet implementation to work with these kind of mechanisms. So that is her intern project. In this blogs, she's going to discuss about what she is going to do, and another blogs she will discuss how it works and the architecture and everything. This is the first article on this series. She has written another article as well, so I hope she will continue this work. So you can closely monitor her blogs and get some idea about how it's implementing. For the next blog, also this is also from another intern who joined to the identity server team. He's Kushan. So you all know there are many new ideas, and these ideas converted into a really good project through the startup. Right? So if the startup started with a good innovative idea, within couple of months or within couple of years, it will become a mainstream project or organization. If it's a customer facing one, there can be millions of users in couple of months or couple of years. So when we think about the startups, sometimes there are limitations of funds, resources, people, so in that case, most of the time we focus on implementing the main components or the main idea we have, right? So in that case, sometimes we miss to give a focus on the managing identity. So if it's a customer-facing solutions that we are going to build, this identity management is a key problem we have to deal with in a couple of months or a couple of years, right? So in that case, it's better if you think about the identity aspect from the beginning. So in that case, this open source solutions will help a lot. So through this article, Kushan discuss about the available features in WSO2 identity server and how these capabilities can be used in the solution that you are going to build in the startup. So if you are building a new solution as a startup, you better read this and see how identity server can be used in your solution. Next, I have select another article from Prabha. So here, he discussed about the maturity model, which can be used for the CIAM solution. Yeah. Having a maturity model, it helps us to understand the status of our current solution. What is the performance and performance and what are the capabilities that we have implemented. And again, going through these maturity models, we can identify how we can improve our existing solution. So that is the benefit of a maturity model. So when it comes to software field, we have different maturity models. So the capability maturity model is a well-known and established maturity model. So this CIMA maturity model also built something very close to the capability maturity model. When we work with the many customers, we have seen their use cases and the solutions they have. So we thought of having a maturity model for the customer IAM. It will help for the organization or the customers to identify where they are in terms of their CIAM solution and how they can improve. Right. So here we identify 4 levels. The first level is the non-existent model, where you may have a basic site or interfacing application for your customers. Sometimes you may not have, and the business will be happen through the SMS or WhatsApp like that, right? So you don't think about the IAM, you don't think about the managing customers and so on. So this is the non-existent level that we are talking. Then it goes to the managed identity level, or we can consider this as a login level, where the customers may have a web-facing application, so it has the login capability, but it doesn't track the users' behavior patterns and their interactions and so on. It just provides a login facility for the users. They just log into the system and do the whatever the transactions there, and then the customers will go away. Then the third level we considered as the siloed level, where you have a kind of IAM solution. Maybe you have implemented the single sign-on as well, but the identity is managed in different phases, different components. Even you may have implemented CRM solutions within the system, but those are not connected. So if you want to generate reports and so on, it's very labor intensive task. So if you get a report to connect it with another report, it's very hard. Then we will go to the next level, which is considered as a connected level. So there we connected all the systems together. So even if we have the implemented the single sign-on, when it comes to this phase, we have implemented the provisioning as well. So within a single place, you manage all the accounts and the user information as well. And the CRM systems and other systems also connected. So you can easily generate reports and you can do those kind of things. The final level, we consider it as optimized level. So all the systems are connected. You may use the machine learning mechanisms to predict how your business goes, and you may have different dashboards, so your CXOs and those level management level people can get good insight about this project. So this is the optimized level we discussed. So you can go through this article and get good understanding about the maturity level. So those are the blocks I wanted to discuss today. So let's get into the today's discussion. Today we are going to discuss about the client-side libraries and SDKs we have built. Previously, one concern we had in identity servers, there were very limited number of client-side SDKs, so it was very hard for the application developers to connect the identity server with the existing application. So sometimes they have to implement the whole client-side authentication or the provisioning from the scratch. So we wanted to eliminate that challenge as well. Now we have started a different effort on implementing the client-side libraries. So we have started implementing these client-side libraries in a new Git organization which is called Ascardio. There we maintain our all the client-side libraries. Today's discussion, we will discuss about few SDKs we have developed. So we'll start with the Android OIDC SDK we have implemented. So Gayashan will discuss about the library we have implemented and how we can use it. So Gayashan, over to you. So, shall I stop the screen so you can share?
So share my screen. So can you see my screen? Hello. Yeah. Today I will be showing you a demo on the Android OIDC SDK that we have developed. So on a high level, I will be going through a sample application that we have created to demonstrate the features available in the Android SDK. So let me briefly go through the introduction section. So in the getting started section, so let's dig into the steps of running this sample application on our local machine. So the very first step is to configure identity server. So here we need to create a service provider for our Android application. So the purpose of this is to secure our Android application using the OpenID protocol. So let me go to the management console and create a service provider. So the next step is to create an OpenID client. So yeah, for the sample application, we have defined the redirection URI screen for the Android app as WSO2 sample. So since we need to use the same for the callback URL of the service provider. So let me configure an node client. Also, we need to enable the following properties when registering the client. So we need to note down this client ID as we need to configure it in the Android website in order to use the SDK. So the next section is configuring the sample application. So you have to clone the SDK repository and open it in the Android Studio. So I have currently done that step and open the project. So once you open that, we need to we have to do the configurations related to the application in the OIDC config.json file, which is available under the res-pro directory. So if I open that up, so there are few properties that we need to configure. The very first thing, as you can see, is the client ID. So the value of this property should be the client ID of the auth client that we created using identity server. So let me copy that client ID and put it in the configuration. So as I mentioned earlier, in the sample application, the redirection URI scheme we have given is WSO2 sample. So we need to use the same for callback URL and define it here as well. And the next thing we need to configure is the URL. So if I go to the config file, so as you can see, so I'm running running my application on the Android default Android emulator that is provided by Android Studio. So in the Android emulator, it refers to localhost by this IP address 10.0.2.2. So we need to put that configuration here. So once we are done with the configurations, since we are building this locally, in order to publish the SDK to the local Maven repository, we need to add these two properties to the build gradle file in the project. So let me show you the build gradle file. So I have added these two properties here. And once you run these commands, the SDK will be published to the local Maven repository, as well as the sample application will be compiled. So I have gone through this commands and build the sample application. So moving on to the next step, there are two sections for each for running Android emulator, or if we are running on Android device. So since I'm running on the Android emulator, there's one thing to notice. Since we are using a local instance of WSO2 identity server, the local instance uses self-signed certificate. So since the IP address of the Android emulator to referring to the local host is different from the usual IP address, which is 127.0.0.1, we need to create a self-signed. We need to create a self-signed certificate with the subject alternative for this IP address, and so that steps are mentioned in this in the subsequent steps how we can generate the key store. Once we generate the key store, we need to copy that certificate file into our Android project. So I have generated the key store file and copied the certificate file, and we need to inform the Android application about this certificate file. So here we can use this property. So this depends on the yeah. So once we have done this, we are ready. We are good to run the application. So as mentioned as a final step, let me run the application on the Android emulator. Yeah, so as you can see, this is our sample application. So here we have, this is a very basic level application that demonstrates the functionality of the SDK. So we have a login button. This login button will initiate the authentication flow. So let me go ahead with this step. Yeah, so now we'll be redirected to the identity server login page. So the service provider I created in the management console. So we have configured basic authentication for the service provider. So as you can see, once we are I'm successfully authenticated. My token details, the token details and my user details can be seen in this application. Yeah. So there are APIs provided by the Android SDK, which we can use to retrieve this information that are displayed here. So to conclude this, let me. So we have included the login functionality in the application as well. So let me show that. Yeah. So yeah, that's that. With that concludes the demo of the sample application. So yeah, thank you.
Okay, thank you, Gasha. So next we are going to talk about the JS SDK we have developed and how we can use that to build a single page application. Tivi going to discuss about that, and he will discuss about the web workers as well, how effectively use that as well. So Tivi, over to you.
Thank you, Vishara. So good evening to you all and good morning to those of you who are joining us from the Americas. So today we'll be discussing about our brand new JavaScript OIDC SDK. I'll be sharing my screen. So I hope you'll be able to see my screen. So here on the right is my is our repo, SDK repo, and I have forked and cloned it into my local machine. So here you'll be able to see the SDK in the OIDC JS directory, and you'll be able to get the sample application from the samples directory. So I have forked and cloned the sample application, and I'll be demonstrating the usage of our SDK using our sample application. So let's get started. So to begin with, we need to import the identity client. And if you are going to use a bundle like Webpack or Rollup, then you will have to import it this way as shown in the documentation. or else if you're going to use HTML file like we are doing to demonstrate the simplicity of our SDK, then you will be able to do so using our library's name, that is Escadio Auth, and you'll be able to use the identity client singleton class, and by using the get instance method, you will be able to get an instance of the identity client uh, class. So first, what we need to do is to initialize our identity client instance. So to do so, we call the initialize method, and to that method we pass a config object which consists of several attributes, some of which are shown here. To get the complete details of the attributes that are available to you, you can refer to our README file and click on Learn More, and you'll be able to get the whole details in this table. So let's get back to the initialize method. Here we need to pass the callback URL as well as the client ID. To do so, you need to create a service provider at the identity server. So here I have already created an service provider. I'll be using the sample service provider. So click on edit, and you'll be able to get the auth client key, which will be our client key from here. So make sure you copy it and paste it in front of this client ID attribute. And at the same time, you'll also have to make sure that the callback URL is the same as the callback URL that you provided in the app. So as far as our app is concerned, the home URL would also be the callback URL. So make sure that this is the same as this one. So once that's done, we'll be able to initialize our instance. But make sure that you focus your attention on this storage attribute, which is a special attribute that actually allows you to store the session information, including the access token, in different storage mediums. The default one is session storage. So if you go to learn more and check out the storage section, that you would realize that we provide developers with 3 options. One is to store the session information in the session storage, as well as the local storage. In addition to it, we also provide this a new feature of storing the session information in the web worker, which I shall be discussing later on during the session. So here in our demonstration, we are going to use the web worker. I'll be discussing about the web worker later, but remember it for the time being that we need to pass an attribute called base URLs if we are going to use web worker. I'll explain the need of it later. And once that's done, what you need to do is to call the sign-in method. So here I'm calling the sign-in method, and all that you need to do is to pass this sign-in method into a function, and this function is an event handler function which should be fired on click. So I have got a button here called sign-in button, and when you click on that button, it will fire the sign-in function, and this function would call our auth sign-in method. So now once you sign in, you might want to carry out certain, execute certain code. So you can use the callback hooks for that. So you need to call the on method and then specify the name of the hook. We have got a list of hooks available, and you can get the details from our README file. So this sign-in hook helps you fire a callback function when the user successfully signs in. So here I have created a hook which will actually get the response from the sign-in method. So you will get the user information as a response once the user signs in, and we'll be showing the display name along with the greeting. So another thing to remember in addition to this is that if you're going to use web worker, again I'll be discussing it later, then you will have to use the HTTP request method provided by our SDK. So you can learn more about our HTTP request method from here. So what this method does is very similar to what Axios, which is a popular HTTP request library, does. So it sends requests to a protected API endpoint and gets the necessary details and shows it back to the user. When you're using web worker, make sure that you use the HTTP request method provided by our auth client, and I'll be discussing the reasons later. So once that's done, we are good to go. So let's go back to our application. So this is the application. So this is a simple application. Just click on sign in and you'll be taken to the single sign-on page, and just enter your credentials and you'll be logged in. So this particular greeting was displayed once the sign-in took place by the callback function. And if you want to get user information, you can just click on the get user info, which would fire that HTTP request method, send the API request, get back the response, and display it on the UI. now going back to our storage attribute, the common problem faced by web developers is about storing the access token and other sensitive session information in a safe and secure manner. If you Google about the different means that you can use to safely store access token, the most recommended method, or I dare say the cliched recommendation, is to use session cookies. But session cookies may not be feasible all the time, especially if your identity server exists on one domain and your service provider exists on another domain, because session cookies can only be used with domains that set the cookie. So in such cases, using access tokens become inevitable. So we have no option but to use access tokens. So let's discuss about how we can safely store access tokens. So the two more commonly used methods are using session storage and local storage. So there are security issues associated with session storage and local storage. To demonstrate the security issues, let me use this simple application. So this is a currency converter. So what it does is, if you enter the currency value in dollars, it will convert it to the relevant value in Sri Lankan rupees. So this is a very simple app, and I have written the app here. So this is very similar to our sample application. So you authenticate yourself. Only if you authenticate, you'll be able to access the app. So once you authenticate, you'll be able to see the UI that allows you to convert the currencies. To convert the currency, actually, I'm using a third-party library called convert USD to LKR. So this library gives you a function called convert USD to LKR. So if you pass the dollar value to it, you will get the relevant LKR value as the response. Now, by the looks of it, this library might seem like a legitimate one, but unless we go through the code, unless we take the pains to go through the code, we will know what the library exactly does. So even though this looks like a legitimate library, let's see what it actually does. So now I have got this in the right side, you'll be able to see a console window. This is actually a server that exists with an attacker. So let's see what signing into this application does. So I'm going to sign in. So I have signed it. Let's see what happens. As you can see, the attacker has obtained our access token. So how did the attacker obtain our access token? Let's get back to our library. So this is the library code that I used. As you can see, this library, as it says on the label, provides us with this convert USD to LKR function, which converts the USD value to the LKR value. But under the hood, it does a lot. So if you go through the code, you will see that it searches for our session storage, gets our access token, and using this send access token method, it sends the access token back to its own endpoint. So what the attacker does is to make use of unsuspecting developers to make them use their malicious library, and by using their malicious library, the attackers are stealing the access token and having the access token sent to their endpoint. So this is a security issue. So to address this issue, again, if you Google, the most recommended method is to store the access token in the memory. So let's try to store the access token in the memory. So let's go back to our app. So here you can see that I'm using session storage to store the access token. So to demonstrate, for demonstrative purposes, let me quickly take access token from the session storage as soon as the user signs in, store it in the memory, and then remove it from the session storage. So to store the access token in the memory, I'm going to use this authentication function. And this authentication function returns an object which has a lexicon scope, and in its lexicon scope, you have this access token. So this is called JavaScript closure, and it is used to safely store variables. So this is akin to private variables in object-oriented programming languages. So if you instantiate this authentication function, you'll get this object, but there's no way you will be able to access this access token. You get two methods. One is to set the access token. So by passing the access token, you will be able to set the access token, but you will not be able to retrieve it. If you have to send a request to protected endpoints, then you will have to use this send request method, which accepts the request as an argument as well as a callback function. So this function would add this access token to the header of the request and would send the request and return the response and fire the callback function. So this is what it does. So let me make use of this authentication function to store the access token in the memory. So let me comment out this particular portion of my code, as well as here, since we don't need to use this anymore, I'll be commenting this out, and I'll be using the send request method of the authentication function that we had just talked about. So once we get the response, we'll be displaying the user details just as we did previously. So let me save this and restart the server. So now I have restarted the server, and let me go back to my app. So let me sign in again. And let's see if the attacker can get the access token. No, the attacker is unable to get the access token. The reason being that the access token is being stored in the memory and not in the session storage or the local storage. But does it mean that it's 100% safe? No. Let's look at an API request. So let's try sending an API request. And as soon as I send an API request, you can see that the attacker has got our access token. So how did the attacker manage to steal our access token, even though we are storing our access token in the memory? Let's once again go back to our code. And again, in the index.js file, which is our library code, you'll be able to see that the attacker is actually attaching a request handler to our HTTP request. So what this essentially does is to intercept HTTP requests and get the authorization key from the header and its value, which will be our access token value. And that access token is being once again sent to that attacker's endpoint. So this way, what the attacker has done is to get the access token. So let's see how web worker prevents it. So let me revert back to the previous state. So let me uncomment this and comment this out. Let me also comment this 2 lines out. And instead of using session storage, now let me use web worker. So let me save this app and restart server. Okay. Now let me get back to my app. Let me sign in once again. So I have signed in, and let's see if the attacker is able to access the token. No, the attacker is not able to. Let me try sending API request again. The attacker is not able to get the access token. Now, what's so special about web worker that it helps us prevent such attacks? So to discuss it, let's discuss the architecture of our web worker implementation. As you can see on our screen, we have got 3 things: the main thread, the web worker, and the backend. So as you know, JavaScript is not a multi-threaded application. You get only one thread. But the problem with using one thread to render front-end application is that when you have to carry out resource-intensive actions, sometimes the UI might tend to get slow, and this might lead to a poor user experience. To address this issue, HTML introduced web workers, which are essentially background threads. So you will be able to offload some of the tasks to the web worker, which means the main thread is free to render the UI. So the user experience will be fast and efficient. At the same time, the resource-intensive actions will be carried out by the background thread. So we can leverage this idea to actually safely store access tokens. The key thing here is that the main thread and the web worker exist in 2 different contexts, which means the code running on the main thread in no way can access the code running in the web worker, and vice versa. If you find this concept tough to grasp, as I did when I learned about it, one easy way of thinking of it is to think of the web worker as a separate server in between the UI and the backend. Even though the web worker is also running in the browser, thinking of the web worker as a server would help us understand the concept better. So we'll be running our UI code in the main thread, and we'll be running our authentication code in the web worker. So the main thread would tell the web worker, hey, I need to sign in. So the web worker, what it would do is it would initiate the authentication flow, talk to the backend, and get the access token. And instead of sending the access token back to the main thread, it will store it in the web worker. So now the access token is stored in the web worker. There is no way a third-party library running in the main thread, however malicious it is, cannot access the access token, because these 2 exist in 2 different contexts. So the only way the main thread can communicate with the web worker is by exchanging messages. So if the main thread wants some information from the web worker, it will have to send a message to the web worker, and the web worker will have to again send a message responding to that particular message. So here, what we are doing is we are initializing signing using the sign-in message. And once we sign in, and if you are to send an API request, the main thread would send the necessary configuration information as a message to the access token. And once that happens, the web worker would attach the access token to the request, and then it will relay the request to the backend, and the backend would respond to the web worker, and the web worker would relay the response back to the main thread. So this way we can make sure at no point the access token is returned to the main thread, and we can also make sure that no code in the main thread can access the access token. And again, we can also prevent malicious codes from attaching request handlers to HTTP requests, because even if you attach the request handler to a request in the main thread, since the requests are being initiated from the web worker, there is no way those handlers would be able to access or intercept the access token. But remember that if you're going to run root third-party libraries in the web worker, then an attacker would be able to carry out the same attack in the web worker as well. So you need to be really careful about the libraries that you use in the web worker. That is only if you're trying to develop your own library. As far as our SDK is concerned, we have make sure that we have minimized the number of libraries that we have used to trustable few libraries. So here you might ask the question why we need to use web worker and why not service worker or iframe. The answer is that if you are going to use service workers have a global reference. So from any part of the code, you will be able to communicate with the service workers. This might not be an issue if you have implemented your web worker properly, or rather the worker logic properly, and make sure that the access token at no point is returned back to the main thread. But if you make a mistake or accidentally return an access token, allowing the main thread to talk to a service worker can become a security issue. So by preventing the main thread from talking to the web worker, we are ensuring an additional layer of protection. And the other problem with service worker is that the service worker is common for all tabs. So if you want multiple users to be logged into multiple tabs, say one user in one tab, another in another tab, you won't be able to do that using service workers. In web worker, web worker is specific to a tab. So if you open multiple tabs, multiple web workers would be spun off. And the other problem, the advantage that you have with web worker is that the reference to a web worker is private. It's not global. So if you're going to use JavaScript closure to safely store web workers, you can make sure that the web worker, the code in the main thread can in no way communicate with the web worker. So when it comes to iframes, even though iframes are also specific to tab instances, they also have global references. So you have the same issue that you will face with service workers. So by using web workers, we can minimize these issues. So that's it from me. So I'll be ready to take your questions if there are any.
So far, we don't have questions, but if any of you have questions, you can put in the chat, so TV or the team can reply to those questions, or even at the end, we can answer the questions you guys have. So thank you, TV. Let's move into our next session. So Chamat is going to do that one. So there we have a Tomcat agent we have implemented. So if you want to enable SAML-based login to your web application which is running inside the Tomcat, so you can use that agent. So this is not a kind of a WAN solution, but kind of enabling the authentication within the application. Chamat will discuss more about that. By the way, I wanted to take thanks Devi. So he quickly ran through the SDKs and how we can use web worker. So thank you Devi for that thing. So Chamat, over to you.
Okay, well, so I will share my screen. Thank you, Shahrukh, for that introduction. So in our today's session, we will look at how we can configure the SAML SDK provided by WSO2 Identity Server into web app to enable, which should enable us to add SAML-based login, logout, and in a very simple and easily configurable manner. So first, to get started, we would head on to the repository that is Asgardio Tomcat SAML agent. When we get there, we can see the README file here. It is pretty structured here. So first, so in this session, I would walk you through this README guide, which would cover the configuring an application, web application to use the SAML SDK. So first, in the getting started section, we need to have two prerequisites at our hand. That is the WSO2 identity server and then Apache Tomcat server. So right now I have WSO2 5.10 running and also the Tomcat server up and running. So the next step in the guide is to configure the sample app. There we have provided the sample app as a resource in the releases. So if you head on to this releases page, there we can find the sample app.wo file. If you click on that, we can download it here, but I already have it downloaded. Yeah, so I will show you what we need to be done. So the next thing we want to do is to copy this into the WebApps folder of the Tomcat server. So we'll go ahead and do that. Yeah. So after that is deployed, we need to configure the identity server for this to work. So we'll head on to the identity server, sign in. Right now I have pre-configured the sample app. To show you the configurations, the main configurations we are concerned about is in the inbound authentication section. There are the SAML configurations. We need to provide the issue ID and the session consumer URL as it is in this README guide. So if you can see here, we have to set the issuer as sample app, and the session consumer URL needs to be this one. So that is what I have configured here. Also, apart from those two, we need to enable attribute profiling and attributes in the response. So that is done here. So the next thing we need to configure in the service provider side is claim configurations. So to do that, we need to go into the claim configuration tab. There I have added a few sample claims here just to demonstrate. So I guess the web app is deployed now. You can see here. To try out the web app, we will head on to this page. Right, so this is the basic functionality of the sample app that is hosted in the repository. So by clicking on the login button, it would initiate an authentication request. It should redirect the user to the authentication portal of the IDP. So next I will add the user credentials. So the user would be logged into this home page. So there are some things to note here. Here we have the user claims that were set in the IDP that has been retrieved in the web app. So if you click on the logout button, it would again redirect you back to the index page. One important thing to note here is that that also explained in this how it works section, that we have two pages here, two pages in this sample app. One is this index page, and that other one was the one I showed you earlier, the home JSP file. So here this index page is not secured. What we want to secure is this home JSP file. So in this section that is explained thoroughly. Following this section, you would be able to understand the code behind that also. But I won't dive into this deeply because in the next step, we would be doing this ourselves as well when we configure our own sample app. So I won't go into this. Right, so this is what our state is. So this is the web app, and I can log in, as I showed you earlier. So if we log out and try out this home JSP file, it shouldn't let me access that page. See, it got redirected back to the login page. So that is it for the sample app demonstration. Next, we would see how we can integrate the Tomcat SAML agent to our own application. So this can be done in two different ways. The first one is to include that in your source project. So that would include building the source from ground up. So that part we won't cover here. Today, what we would look at is how to integrate the Tomcat agent into an existing web app. So to do that, we would follow this guide. Here also we have the Tomcat prerequisite to have. So the next thing is this guide is based on the configuration of a very simple app. The structure is shown here. So what I also have a similar web app open in the VS Code here. So this only have 2 pages, a simple index page and a home JSP file. Right now there is nothing secured here. What we have is only some redirection from index to home. So this is the exact structure we have in this guide also. So to show you what the app is, where the app is at right now, I will deploy this WO file of the sample app to the Tomcat Web Apps folder and show. So it shouldn't take much time to, yeah, it already has been deployed. So we'll go ahead and click on my app. So this is as same as the sample app I showcased earlier, but here there is no authentication request sending. So it would only forward the user to the home page. So at the end of this, what we want is to just have some security for this home JSP file. Right now, this only just forwards. So we'll go into the VS Code here and follow this as well. So first step, what we need to do is download this lib.zip file from the releases. I already have the releases open here. So if you click on this, we can download that lib file. And the next step is to extract the downloaded file into app home web inf directory. So I have the lib file as well downloaded. So I will go ahead and we don't need this one now. Copy that into web.inf or extract that into web.inf. So this is not needed anymore. Next, right. So we are at here. So next thing is we need to configure a file named sample app properties. So right now in my web app, I have named this as my app, the context. So I will create a sample app the properties file as instructed here in the classes directory, but I will name it as myapp.properties. Myapp.properties, right. Next, for the time being, we would blindly copy the configurations here, paste it here. Then we will closely look at all these few of the key configurations. First one I want to note is this skip URIs. So currently we only have 2 pages. So if we have multiple pages and we only want to like secure a couple of pages, we don't want other pages also to be secured, we can add the pages we don't want to secure into this skip URIs parameter in a comma separated way. So that way the SDK will identify that these pages are not needed for to be secured, and it will only secure the excluded files from this tag. The next parameter we have is the index page. Here I need to change this because my app context is actually my app. So the next one is SAML to ID, SP entity ID. This also I will, for the uniformity, I will change it to my app here too, and save the file, right? That's everything we need right now. So the next step in our guide is to generate the key store file. In here also, for simplicity, they are recommending to use the keystore which is in the IS home security directory. So we will do that as well. So we will go into the WSO2 IS 510 resources, not resources, repository, resources, security, and copy the WSO2 carbon JKS and paste it in the classes directory in the app, right? So that is done. And the next thing we need to do is copy the web-inf, actually the final thing we need to do. So we'll go ahead and copy this thing, just blindly copying, and we'll move ahead to the VS Code and paste the whole thing here. Here also we need to make sure that these param values are updated to our files. So these two are the files we need to make sure that we change. Here my name is the app I have here. It has myapp.properties. So that I will change here. The key certificate file, that doesn't need to be changed. So that is fine as it is. Right. So the next thing is about configuring the pages of the web app. So right now in the index file, this only the action is set to home JSP. So when we click on this in login button, the user will be forwarded to the home JSP. What we need is to forward him to create an authentication request. To do that, we need to copy this action and paste it here. Right. And also we need to enable logout. In the home, right now it only forward the user to index.html. So need to change that as well. So we'll copy this and paste it here. I missed something. Yeah, that's fine. Also, next thing that is a bit tricky part, that is where we retrieve the user attribute. So with these two configurations, we can actually secure the app, the pages we want. But if we want to go ahead and retrieve user attributes as well, we need to add this code into whatever the page we need our user attribute. So currently it is the home page for us. So we go ahead and add these things. Right. Just blindly copying. Okay, so I'll add it somewhere here. Right. So what happens is the claims are retrieved from the IDP and it is stored in this map object. So the next part is to display these properties in a way. So there, for that we have added, we are going to add a table tag here and display those properties here. Right, that looks fine. Save it. Okay, so that is all we need to configure on the app side. Now we would go ahead and deploy this app. To do that, I would just clear this out and populate my app. Create myapp.wo file here. So it should be created in the myapp directory, right? Okay, so I will copy this and we don't need this one right now. So I will paste it in the web apps folder. The next part is what where we need to configure the identity server. That is very similar to the configuration I showed you earlier. So I won't take much time. I will skim through the steps. These are the exact specific steps we did earlier. So I will go into management console and click on add a new service provider. The name here doesn't matter actually. You can choose whatever you want here. Here also what does matter is the inbound authentication configurations. So there are I'll click on SAML to WebSO. So here's the important part. The issuer ID here we need to set the exact issue ID we had set in the properties file. So in our case, it is my app. So I will copy this, paste it in the issuer. And in the ACS URLs, we need to have the exact same ACS URL as in the properties file in the SP configuration. Let that there. And as shown before when running the sample lab, we need to enable these two properties as well. Next, I will quickly add some claims just to showcase the claim retrieval. I'll add what country, another one. Actually, I have to configure those things. So, email address, and I'll add one more just for good measure. All right, this so it's to full name. That is fine. So that looks good. We'll go ahead and update. So right now we have deployed the app. We have configured the service provider. So we will try the app and see if it works. So for good measure, I will take a private tab. Okay, my app. Now it should initiate authentication request. Okay. You will use the same user you used before. The consent page. Right. So we have the claims and we have the home JSP page. So let's see what happens when you click on logout. So it redirects you back to the index page. So if you try to access the home page now, yeah, it doesn't let me access. So that's it from my session. So I hope you got something out of it. If you have any questions, you can reach us out at the Stack Overflow and also at our Slack channel. So yeah, that's it from me. Thank you. Over to you, Shara.
Yes, thank you, Chamath. So before I wrap up, let me quickly show the SCARDIO organization. So here you can find all the SDKs and agents we discussed. So here we have only few, but we are working on other libraries and SDKs. So please use these SDKs and agents. So give your feedback to us and then create issues if you face anything. And then more importantly, please contribute to these projects as well. So that is all we have planned for today. If you have any questions, please come back to our Slack channel and ask any question. So we are happy to help you or discuss with you anything related to identity server, so we can improve. So thank you all for joining today's call. Stay safe and have a good day.